Hello, and welcome to 5 Minutes With, a podcast by Geoscientist magazine. My name is Marissa Lowe, and today I'm joined by Dr. James Mortimer from the Open University. Thanks for joining us, James. Can you tell us what you're currently working on?
Hi, very nice of you to have me. I work on several different projects at the moment, but the main one is called Prospect, which is a European Space Agency package designed to go to the moon and explore for volatiles and other resources of interest, such as water ice, that might be used in the future to support human exploration of the solar system.
Fantastic. You mentioned water ice and other volatiles. Can you tell us a bit more about that? Why are we interested in that?
So these are things that are supposedly present at the lunar surface from orbiting missions that we've seen signals to suggest that things like water ice might be present. But in terms of going and making a ground truth measurement to verify those orbital measurements, we haven't yet done that. So this is a sort of next step on in our exploration. These are some important, useful tools. Things like water, you can use it as water to support human life, but you can also break it down into hydrogen and oxygen, which can be used in many different ways, either oxygen to help breathe or the hydrogen you can use to make various fuels. It's really about providing resources, looking at how we can extract any resources that might be there, what quantities they're in, where they came from originally, how quickly are they replenished if we use them, to really extend this idea of a sustainable human presence beyond low Earth orbit.
Can you tell us a bit more about the Prospect mission?
So Prospect is a package of instruments being developed by the European Space Agency and hopefully going to be flown. We're manifested on one of the NASA CLPS commercial lunar payload landers. If things stay on track, we should be going to the moon in the late 2020s. We're at the stage now where we're just finishing off the final designs and ready to start building some of the real models of the instrument, how this works. So Prospect as a whole is basically two components. There's a drill, which is being provided by our Italian colleagues at Leonardo in Italy. Then we have the bits that we're doing at the Open University, which are the analytical lab, the instruments that will actually analyze the samples collected by the drill. So it's a little carousel of ovens where the sample will be deposited. It will be heated up to whatever temperature we want, up to 1,000 degrees Celsius. And that will drive off any of these volatile elements that are present. And they will travel as a gas into our shoebox size analytical laboratory, which contains two different mass spectrometers. So one mass spectrometer can be used to essentially sniff whatever's there. It can scan across a whole mass range and in real time look at what components are being given off by the lunar soil. The other one is a magnetic sector mass spectrometer, so that we will use for more precise isotopic explorations. So we might be interested in looking at the isotopic signature of the hydrogen in any water ice that's present in the sample. And that could give us a fingerprint for where that water came from in the solar system originally. So it's quite a complex bit of kit. It shrinks down something the size of a small car in the laboratory down into something the size of a shoebox. And that's what's taken us several years to get to this point. And now we're ready to start building. That's quite exciting.
What is a typical day for you at the moment?
Quite variable, actually. Some days are very lab-based. So part of my job is looking at things like contamination and the impact that any contamination could have on the science that we get at the end when we're actually working on the moon. Some days I'm in the lab and I'm running experiments, testing out different cleaning procedures, looking at contamination loading. Other days I'm writing reports. So working on a mission like this, there's a lot of paperwork that has to be done to document each stage of the process, because that's very important if someone comes along in the future and wants to adapt what you've already done. And other days it's a real mixture. As I said, I work on several different projects. So sometimes you're flitting between different things, meetings as well, lots of meetings to attend where you're collaborating with international colleagues, but also within the team.
What's your favorite thing about your work?
So I started off as a sedimentary geologist as an undergrad. And what really drew me to doing something more lab-based for a PhD and now for my job was that exploration, finding a new piece of data, and that bit of time you have when you've got some data, you're sitting there and you're processing it, and you realize the story that it starts to tell you. And for a little while, however long it takes you to process the data, and then before you write it up, that's your knowledge. No one else knows that. You've got an answer, and it's such a rewarding feeling, that realization of something new that only you know. It's a little treat. It's what keeps you going.
So what advice would you give to someone hoping to work in your field and find their own answers?
I'd say don't be afraid to try different areas. Don't be afraid to branch out into different fields, because you never know where things will develop and where they'll take you. If I'd stayed doing what I'd originally thought I would do, sort of sedimentary trace fossils, things like that, then I wouldn't be involved in an exciting space mission at this point in my career. So never be afraid to try something different, to branch out.
Thanks so much for joining us, James. All the best with the Prospect mission.
Thank you very much.